So now this is the fifth type of question when k is very small. So when k is very small, that is k is less than 10 to the power of minus 3. So if you have values of k like this is super small values of k. So see here, to the power of minus 18 to the power of minus 31. So these are very small values of k. And we've seen that when k is very small, it means that in the equilibrium mixture, you have many reactants. So you don't have a lot of products that is produced. So which means that the equilibrium lies far to the left. So you have reactants and then you have products. So the equilibrium lies here. It lies far to the left, which means that at equilibrium, the amount of reactant is pretty much the same as the amount of reactant that you have in the beginning, because it's not going to change. So if this is the initial and this is the final at equilibrium, so this amount of R is going to be very similar. They will change by a value that is so small that these two concentrations could be seen as being almost equal to. So when we have very small values of K, we use this approximation that concentration of reactants initially is almost equal to concentration of reactants at equilibrium. So let's see how this applies. So it says that the value of K is this. So you can see that K is very small. And it tells you initially you have this much of N2 and this much of O2. When you have these questions, you will not use the Rice method. It's not going to apply. You don't have change. You don't have initial change in equilibrium because, like I said, the change is going to be very small. Change is too small. So we're not going to have that table here. But we know that initial concentration of N2 is this. And initial concentration of O2 is this. So for this, we can write an expression of K. K is concentration of products raised to the power divided by concentration of reactants raised to the power. We know that K is this. Concentration of NO is unknown. I'll leave it as it is, or if you want, you can put it as X. So it's going to be X squared. And then N2 is given. And then O2 is also given. From this, you can cross multiply. You can find the value of X squared. And from value of X squared, you can find the value of X. And this is going to give you the number of moles of NO at equilibrium. So normally this is what you're supposed to get. Now when you're doing these questions, you will never get a quadratic equation. The quadratic equation is not in your syllabus, so you will not get a quadratic equation. If you find any reaction where you're getting a quadratic equation, means it's wrong. Let's try number 2 now. So the value of K is given here. So just remove the C here. So it's just K. And this is the equation given. And the initial concentration of H2O is given here. Now, we can look at the K and we find that K is very small. So much less than 10 to the power of minus 3. So it's very small, which means that the equilibrium lies to the left, and which means that the initial concentration of H2O and the final concentration of H2O is going to be almost the same. So in this kind of question, I can write the equation and I'm going to apply the Rice method with a little variation. Right, so that's the ratio. Initial amount of H2O, it's this, and final amount of H2O, it's still this. Because it's going to change by very small amounts, so it's almost this. Now H2O is going to form H2 and O2. Initially there's no H2 and there is no O2. Now H2 and O2 will increase. They will increase by very small amounts. Let's say oxygen is going to increase by X. Now because ratio is 2:1, if oxygen increases by X, H2 will increase by 2X. So this is going to be 2X and this is going to be X. From this we can write an expression. So K will be equal to this, and I can fill up the values of K here and the value of H2, which is 2X square. Oxygen is X, and then divided by the amount of H2O, it's this to the square. From this, I can find the value of X. So 2X square, that's going to be 4X square times X. That's going to give me 4X cube, and 4X cube is equal to this. So using this, you can find X. So you're going to do the cube root of the answer that you get here. And you can find your value of X. You can verify if you get this answer. So then H2 concentration is 2X. So 2 times the answer. So you can calculate this. Using the same principle, complete example 3.